Hello everyone, good afternoon to all of you. Myself Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this lecture, I am going to discuss about the solutions of question bank from Module 5, Vector Calculus. The name of the topic is Part A, Problem Solving and Critical Thinking Questions. So here I want to discuss about the problem solving and critical thinking questions in detail. First of all, I want to suggest two references of textbooks. First reference of textbook, the name of the authors are N.P. Wali and Dr. Manish Goyal. Publications, Lakshmi Publication Private Limited. And the second reference of textbook, the name of the authors are H.K. Das and Dr. Rama Verma. Publications S. Chand and Company Private Limited. So today in this lecture, I want to solve some problems solving and critical thinking question from Module 5 Vector Calculus. So here question 1, verify Gauss divergence theorem. Gauss divergence theorem for the function vector point function is given f vector equal to x square I plus y square j and plus z square k taken over the cube bounded by x equal to 0, x equal to a, y equal to 0, y equal to b, z equal to 0, z equal to c. So solution. So this problem is very important problem and also very interesting problem, and we want to solve this problem based on solving and critical thinking questions in detail. So here given us that vector point function is given as that here f equal to x square I plus y square j and plus z square k. This is vector point function. Taking over a cube, x equal to 0, x equal to a, y equal to 0, y equal to b, and z equal to 0, z equal to c. This is a cube bounded by these are limits of cube. So now verify Gauss divergence theorem. Here we want to verify Gauss divergence theorem. So first of all, statement of Gauss divergence theorem. Gauss divergence theorem. Gauss divergence theorem. Okay, Gauss divergence theorem. So here double integration vector point function f n dot n vector, n is the unit normal vector perpendicular to the surface outside the surface. So n this equal to here triple integration divergence f vector and here dv. This is the statement. Here is S and here is volume B. This is known as a Gauss divergence theorem. Formula for Gauss divergence theorem. Okay. Here surface integral, left hand side is surface integral and right hand side is volume integral. So both sides should be same according to given condition. So here we find out the first LHS. LHS double integration vector function f n dot n unit normal vector and ds. Here is ds. So here is ds, this equation 2, left hand side. Okay, where n is a unit normal vector, perpendicular to the surface, perpendicular to the given surface, outwards. Okay, the direction of the unit normal vector to the given surface outwards, not inwards. This is an unit normal vector, and a unit normal vector which is perpendicular to the given surface outwards. Direction of the unit normal vector is to the outwards of the given surface. The direction of unit normal vector to the given surface vector outwards to the surface. Okay, so here integral this vector f and dot n into ds. ds means dx and dy. This equation 3. Now here making diagram. This is x-axis, this is y-axis, and this is z-axis. This is origin. And here is cuboid. Cuboid is this type. This is cuboid. So here OA, BC, OABC, O, A dash, B dash, C dash, and D dash. Okay. So there are 6 surfaces in this cuboid. There are 6 surfaces in cuboid. Okay. Next, this is LHS. Now RHS is triple integration volume B and divergence F dB. Okay. This equation 4. This equation 4 RHS. This equation LHS 2. Okay. We have to prove LHS equal to RHS. We have to prove equation 2 and equation 4. We have to prove here, prove equation 2 equal to equation 4. Equation 4. So we have to prove this here. Integration here is s f dot ds n into ds is equal to triple integration volume b and the divergence F and dV. Okay, this is a statement. Again, right. So now, first of all, I am proving here RHS. RHS. So now triple integration. Here V divergence F and here dV. dV means dx and dy and dz. Okay. So now this equal to here integration, triple integration, divergence F here del dot F. F is here x square I plus y square j and plus z square k, and dx and dy and dz. Okay. Now this equal to triple integration. Here I dou over dou x plus j dou over dou y plus k dou over dou z. This is the value of del. And here dot x square I plus y square j and plus z square k, and dx dy dz, where del equal to I dou over dou x plus j dou over dou y and plus k dou over dou z. This is value of del. Now we putting here value of del, and this is the function f, vector point function, dx dy dz. So now taking dot product. Here taking dot product between I to I. Here I to I equal to 1, j to j equal to 1, k to k equal to 1. I dot j equal to 0, j dot k equal to 0, k dot I equal to 0. So now we get here RHS, triple integration, here dot product, taking dot product here, dou over dou x of x square plus dou over dou y of y square plus dou over dou z of z square, and into here dx, dy and dz. Okay. So now this equal to triple integration. Here 2x plus 2y plus 2z dx plus dy plus into dz, dx dy dz. So now triple integration here, integration x equal to 0, x equal to a, y equal to 0, y equal to b, and z equal to 0, z equal to c. So x plus y plus z and dx dy dz. Okay. So 2 is common here. Now this equal to 2 is common, integration. Here first of all x equal to 0 and x equal to a, integration y0, y equal to b. Now integration with respect to z here. So writing here x plus y into z and plus z square y2. Integration of z, z square y2, and x plus y constant. So integration here 1 with respect to z. So we get this result here. Now here apply limit 0 to c and dx dy. So now here twice of triple integration, double integration 0 to a and 0 to b. So here apply the limit. Here c, x plus y into c, x plus y into c minus c square y2, and minus 0 minus 0. here dx and dy. So c is common here, 2c. 2c is common. So here 0 to a and 0 to v. X plus y plus cy2. dx and dy. Now this integration with respect to 2c, again integration with respect to y. So here 0 to a and here y. Integration with respect to y. So here xy plus y square y2 plus cy2y. Okay. And here is dx. Integrate limit 0 to v. So this equal to here 2c integration 0 to a, and now limit putting y equal to v and 0. So here x into v and plus v square y2 and plus cv y2, and here dx minus 0 minus 0 minus 0. So here is dx. Lower limit is 0. So here putting y equal to 0, here y equal to 0, here y equal to 0. So c into b by 2. Now this equal to 2c. Here is b is common. So b is common here, 0 to a and integration x plus b by 2 plus c by 2 and integration dx. So now here 2bc, here x square by 2 plus b, here x, bx by 2 plus c by 2x. Limit 0 to a. Putting x equal to a here. So 2bc and here a square by 2 plus ab by 2 plus ac by 2. Okay. A is common and 2 common. So here 2abc y2, 2 is cancelled, and here a plus b and plus c. So this is the value of right hand side, abc into a plus b. So we get here right hand side value of RHS. This equal to abc and a plus b plus c. Now value of left hand side. Value now left hand side, second result. This is first part. This is first part. Part 1. Now part 2 is part 2. Double ये है LHS. LHS left hand side. Double integration f vector dot n vector and ds. So double integration f vector dot n vector and dx dy. Okay. So now S1 is integral with respect to surface xy surface. Okay, xy surface. So xy surface n vector equal to minus k vector, n equal to minus k vector, and here f vector equal to minus k vector. Then here double integration and xy equal to z0 in xy surface. In xy surface z equal to 0. So z0 means dz equal to 0. Now this condition apply here. So here is x square I plus y square j and plus z square k. And here is along the integral along the xy surface. So xy surface, the direction of n is minus k. So n is minus k. So now putting here and dx, here dy, ds. So dx dy. Now putting z equal to 0 and dz 0. So z0 is this. Now double integration here. Double integration here. Putting dot n equal to minus k. Minus k. So here dx and dy along xy plane. Z is 0 there. So here integration this multiply to minus k. So here is minus z square and z is 0. K dot k, other results are 0. So integral is 0. This z square and z is 0 result here. Dx dy and z is 0. So S1 result is 0. Here this implied that S1 equal to 0. Okay. Integral along xy plane. S1 is result 0. Now S2 is integral a plane along a plane which is parallel to xy plane. Means parallel to xy plane means A dash, B dash, C dash, D dash. Plane A dash, plane A dash, B dash, C dash and D dash. In this plane, the value of Z equal to C. Value of Z equal to C. So dz equal to 0. Okay. There is increment in only Z. X and Y are constant. So here we write S2 equal to double integration and now n is k here. F vector dot n vector and ds, dx and dy. Okay. So here z equal to 0 and dz 0. Z equal to 0, dz 0. Z equal to c here. So n equal to k. N equal to k here, xy plane. So now this equal to here S2 double integration f is x square I n plus y square j n plus z square k n into n is k vector and dx dy. Okay. So this equal to double integration. Here k dot k. K dot k means only z square. Dx dy. And this equal to S2. Here double integration 0 to a and 0 to b and putting z equal to c here. Z equal to c, dz equal to 0. So here c square and dx dy. Okay. So now integration here c square integration of dx 0 to a and integration of dx and into y square y2 and limit 0 to b. So this equal to here c square, no y square y2 nahi, only y only integration and limit 0 to b. So c square b and into integration 0 to ax dx. Now this equal to c square b and x dx. Z square c here is dx only. So integration is dx. So integration here x and 0 to a. So here c square b a minus 0. So this a b c square. This is S2. Okay, and similarly we can find S2, S3. S3 is the S3. S3 is the YZ plane. YZ. YZ plane passing through origin. Origin. Similarly, we can find S3. S3 is the YZ plane. YZ plane passing through origin. So this is plane is here YZ. Y and Z. This Y and Z. So here O, C, C dash, D dash. O, C, O, C, C dash. O, C, C dash, D dash. O, C, C dash, D dash. Here YZ. X equal to YZ. Plane. So X equal to 0 here. Dx is also 0. Okay. So S3 is 0 here. Because here apply the integral f dot n ds. So here dx is 0. This equal to here apply integration y square x square I plus y square j and plus z square k and into here n. What is n? Direction of the this n. Direction of the n is I. So n is parallel to I. N parallel to minus I. Okay. Perpendicular to x, y, z. X, y, z outwards. So outwards is n, a vector n is I vector. So writing here, this is I. N vector equal to minus I. So here writing this is point here. So here writing minus I. And into ds. ds means dy and dz here. Plane along yz axis. So now I am writing here integration x square and dy dz. What x is 0? What x is 0? So S3 is equal to 0 here. Okay. Putting this value here, then we get 0. S4. S4 is the surface parallel to yz axis. YZ axis. Okay. So here x equal to a. X equal to a. This implied that dx equal to 0. Here x equal to a, dx equal to 0. So now integration here x square dy dz. So x square is a square, dy dz. So this result x equal to 0 to a, dy by equal to 0 to b and 0 to c. So after solving we get this result a square and 0 to b dy and z here. So integration 0 to c. So now a square c integration 0 to v and dy. So we get here a square c and y 0 to v. So here a square bc. This is S4. Okay. So now S4 equal to a square bc. And S2 equal to ABC square. Similarly, S5 is the surface xy, yz and zx. surface is ZX plane passing through origin. Passing through origin. So S5. So S5 here ZX. Which is the ZX? Z and X. Z and X. This plane. So this plane is ZX plane. ZX plane is this. This Z and this X. So here OA, A dash, D dash. OA, OA, A dash and D dash. This is the plane. In this plane, here y equal to b. Y equal to 0. Y0 means dy 0. Dy 0 means n is perpendicular to n is k. N is y. N equal to j. So now here double integration S5 is double integration means here x square I plus y square j and plus z square k and dot n. N dot means dot j and here dx and dz. Dx and dz. Now y equal to 0. So this result equal to here double integration. This is only y square and dx dz. But y is 0. But here y is 0. So y is equal to 0. So here putting S5 equal to this is 0. Now S6. S6 is the surface. This is parallel to ZX axis. S6 is the surface parallel to Z axis, XZ axis, ZX axis, ZX plane. So here x equal to ZX plane. So y equal to b, and dy equal to 0. So here writing same result as 6 equal to here double integration y square equal to y is b. So here is b square and dx dz. So here 0 to a and 0 to c. So here after integrating b square ac. So now total area of the surfaces. Total area of the surfaces. This equal to S1 plus S2 plus S3 plus S4 S5 plus S6. So S1 is XY plane 0 plus here is S2. What is S2? S1 0 and S2 is ABC square. S2 is ABC square. ABC square plus AB square C and plus A square BC. Okay. So now ABC is common. So now S1 total area of all surfaces S1 plus S2 plus S3 plus S4 plus S5 and plus S6. So S1 is 0 plus ABC square plus 0 plus AB square C plus 0 plus A square BC. Okay. So now ABC is common. So this equal to A plus B and plus C. So this is the total area of the all faces. So this result is, this is left hand side result. So now, so here LHS equal to RHS and equal to ABC, A plus B plus C. So Gauss divergence theorem is verified. Is verified. Okay. Gauss divergence theorem verified. So here we have given a cuboid, and in cuboid there are 6 faces, xy plane and parallel to xy plane, yz plane and parallel to yz plane, zx plane and parallel to zx plane. So here 6 planes are there. So we are find the area of all 6 planes. So one planes which is passing through directly origin, that have 0 value, and the plane parallel to given plane that have value. So one plane have 0 value and other parallel plane have some value. So there are 3 planes have 0 value and other 3 planes have value. So the total of all faces are all planes. The area of total all faces are ABC plus A plus B plus C. And we have already find in RHS the volume integral. With the help of volume integral, we have already find the value of volume integral ABC and break it A plus B plus C. So Gauss divergence theorem is verified. Now here second problem, using Green's theorem, in the plane evaluates this value. We are evaluating this value where C is the region bounded by these curves, bounded by these limits. So here solution given us that integral C 2xy minus x square dx and plus x square plus y square and dy. Okay. Limits are y equal to x square and y square equal to x. These are the limits. So now, first of all, I am writing Green's theorem. Statement of Green's theorem. Here we know that the statement of Green's theorem is here integration m dx plus n dy. This is integral C, line integral. This equal to line integral equal to area integral, a double integration. Double integration dou m over dou y, dou n over dou x minus dou m over dou y and dx or dy. Okay. This is area integral region R. This is a statement of Green theorem. Here LHS is given. Here in our question LHS of Green theorem is given. Okay. So here theorem integral C m dx plus n dy. So this equal to Here given integral c. So what is this 2xy minus x square? 2xy minus x square dx and plus x square plus y square dy. X square plus y square dy. Okay. Comparing on both sides. Comparing on both sides. We get m equal to 2xy minus x square. M equal to 2xy minus x square. N equal to x square plus y square. So here now we get dou m over dou n over dou x, dou n over dou x, differentiating m with respect to y. Then we get dou over dou y of m. M is here 2xy minus x square. So this is only 2x. Okay, dou m over dou y. This is dou m over dou y. Differentiating n with respect to x. Then we get dou n over dou x. Dou over dou x of n, x square plus y square. So this is also 2x. Okay. Dou m over dou y is 2x. Now this is given here, this equation. This is Green's theorem 1 equation. And this is 2 equation. Comparing on both sides, we get here 3. This is 3 equation. Differentiating m with respect to y, we get here this equation 4. And differentiating with respect to x, differentiating n with respect to x, differentiating m with respect to y. So this equation is 5. This is dou n over dou x. This is equation 5. Now putting in Green theorem. All values putting in Green theorem. All values putting in Green theorem. Green theorem. So Green theorem is here m dx plus n dy. This is integral c. This is line integral. Basically, this is the relation of line integral to area integral. So this equal to here double integration region R. Here dou n over dou x minus dou m over dou y and into dx dy. This equation 1. This is line integral equal to area integral, region area integral. Area integral. So we have given line integral here c. M is 2xy minus y square. 2xy minus y x square. 2xy minus x square. And dx. And plus here x square plus y square and into dy. So this equal to here double integration dou n over dou x 2x and dou m over dou y. This is minus 2x. Dou m over dou x. Dou n over dou y. So dou n. This is n. M is 2xy minus x square. N is this. So n is with respect to x 2x. N is with respect to y. M is with respect to x and n is with respect to y. M is with respect to y, that is 2x. And n is with respect to x, that is also 2x. So this is 0? No. m is with respect to y means 2x, and n is with respect to x. So dou m over dou y 2x, both are 2x, here is minus x. So m is with respect to x here. Formula is wrong. M is with respect to x, dou m over dou x minus dou n over dou y. So here is 4x, dou m over dou x, dou m over dou y. Differentiating m with respect to y. Y means 2x. And differentiating n with respect to x. This is 2x. Okay. So write this value here. This is minus 2x. And here dx dy. So this value has here 0. 0. dx and dy. So total region have 0 value. Okay. Here dou n over dou x minus dou m over dou y. N is x square plus y square. So differential of n with respect to x. If we interchange, then what happens? Dou m over dou x. Dou m over dou x means 2y minus 2x. 2y minus 2x. And dou n over dou y is 2y. 2y minus 2x and 2y. So 2y is cancelled. So this result is 0. Okay. Dou n over dou x minus dou m over dou y dx dy. So n differentiating with respect to x and m differentiating with respect to y. So here m with respect to y here 2x. So m with respect to x here 2x. So region is 0. So this is the 0 answer. Okay. In this region, the right hand side region have 0 value. So left hand side line integral is equal to 0. So we have 0 value. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.